Okay, so let's talk about product of powers rule. So if I have common bases, that's what these two are. X and X are common bases. Their exponents can be added. And I like to think of it as, I just speak what I'm looking at. If X A times and X B times, then I have X A and B times. I'm going to say that again, using this. If I have n cubed and I have n squared, don't I have n cubed and squared? And usually means add, correct? So n cubed is n times n times n. It's n times itself 3 times. And n squared is n times n. So if I add the two together, I get n to the 5th power. So I'll let you write that down if you don't already know that. Okay, so let's move on. A power of a power rule. So this one changes. Now I have x to the a b times. This quantity inside of here is x to the a b times. Well, when I say a b times, I'm really saying a times b. So I'll say it again this way. I've got n cubed 2 times, which means n times n times n 2 times, which is n cubed 2 times, which is n to the 6th. Or I could look at it like this. 9 cubed 12 times is like saying 9 cubed 12 times. Now, are you starting to kind of catch how I'm saying it? 9 cubed 12 times is different than n cubed and n squared. See the difference? The first one, this one I'm saying and, so I'm adding. This one I'm saying times, so I'm multiplying. That's the way I remember it. When I was your age, I actually would put a multiplication sign right here, and I'd say to myself, I can fit a multiplication sign there. Can I fit an addition sign there? Not really, not like I can here. See that? That's the way I remembered it. Now I just speak it. Okay, so should I leave it on the screen for just 1 second? Let you guys copy that down. Okay, so let's work on some of these together. All right, so I have 7ab times 2a squared. All of this is multiplication. So what property tells me that I can go ahead and move this stuff around? Commutative. Perfect. So I'm going to put my constants together. So I have 7 times 2, a to the 1st power, a to the 2nd power, being multiplied, b to the 1st power, and that's it. I should change my color.
Yeah, maybe.
I'm regretting that now. Let's see if I can still change it. No, it won't let me. Okay, so 7 times 2 is 14. A cubed and a squared is a to the 3rd, right? Because I have 1, and then I have 2 more being multiplied by each other, so I have a total of 3 being multiplied by each other, times b. So that's that one simplified completely. Let's try this one. I've got a negative, this time I'm going to change my color. I've got a negative 3. That one's done. I've got a k to the 1st power, a k to the 4th power, an x squared, and another x squared. So I have a total of 5 k's being multiplied by each other and 4 x's being multiplied by each other.
Is that the work we have to show?
Yes. No. I could have gone further. I could have made you do this.
Never mind.
Oh,
Right?
That's just,
Okay, well then let's not complain.
want me to throw my pencil while you're recording?
Okay, so let's do this one. This is a quantity in here, right? In front of this 4, there's a negative. So that negative is its own constant. It stands for a -1. Correct? So this is saying this time, I have everything in here. I'm going to multiply it by itself 2 times. So I could rewrite this as -4x squared y times -4x squared y, or I could just go straight to distributing this square to everybody inside the parentheses, which would be negative squared, 4 squared, x squared 2 times, and y squared, which gives me a negative times a negative is a positive. 4 squared is 16. X squared 2 times is x to the 4th, y squared. And Justin, you don't have to do this step right here. This one and this one is sufficient. Okay? Let's look at this one. So I'm going to go straight to the distributing. I'm going to distribute a cube to everybody. So I have 2 cubes. This time I'm not even going to use parentheses. I have a squared 3 times. I have b cubed 3 times. And I have c to the 5th 3 times. You can do it this way with parentheses, or you can do it this way with multiplication. Same thing. So 2 cubed is 8. A squared 3 times is a to the 6th, b to the 9th, and c to the 15th. Last one. This one gets a little more complicated. This is a little more like what your homework's going to look like. You guys ready? You can still see 3 and 4. Do you guys need 1 and 2 still? All right, I'll pause for a second. All right, so let's work this one out. Now, just like Justin said, complaining that he can't skip steps, this is one of those where I wouldn't skip any steps. Okay, because you could get the wrong answer real quick by skipping steps there. So I'm going to distribute. It's just the difference between an A and a B sometimes, right? Okay, so 2 squared, A cubed 2 times, B to the 5th 2 times, C squared. All of that times, I've got a negative that I'm going to cube. I've got a 2 cubed, A cubed, and B to the 4th 3 times. So this is 2 times 2 is 4, A to the 6th, B to the 10th, C squared, negative times a negative times a negative. I can just throw a negative out in front there. 2 times 2 times 2 is 8. A cubed and b to the 12th. I like this example because I was able to use the power to a power rule, and now I'm going to use the product of a power rule, right? Because I've got a to the 6th and a cubed. So since I have a to the 6th and a cubed, I'm going to add the 2, right? Add their exponents. Let's start with our constants, though. Let's change our color. I've got negative 4 times 8 is negative 32. A to the 6th and a cubed is a to the 9th. I kind of like to cross them off, too, after I simplify them. That way I know I've got everything I need. And b to the 10th and b to the 12th is b to the 22nd power. So I've got everything. Oh, look at it. I didn't follow my own rule. C squared. See how it's useful to cross things off as you go? Yeah, is it very taken care of? Yes. Questions on this? Yes. Because 10 and 12 is 22. Sorry. Kind of does look. See how right here it's 5 times 2 is 10? Everybody good? May I go? Okay, so pencils down. Let's just pay attention. All right, so here's our big idea that we're going to look at next. So negative exponents are positive fractions, which makes sense if you think about everything in math has inverses, correct? So if I have a -1, I don't like negative exponents. And actually, this is a x over 1, right? If I wanted to have a positive exponent, I can put it in the denominator and make it positive. Because the inverse of the numerator is denominator, and the inverse of -1 is +1. Okay? It's just like if you have the opposite. Let's take 8. If I have 8, and I say, okay, I'm going to take the inverse of 8, that's -8, and another inverse makes it +8 again. It's like that with anything in math. You take 2 inverses, and you get a positive. Here's another one. Did you guys know you could do this? If I take the inverse of this side, I can also take the inverse of that side. As long as you do 2 inverses, it's like this guy right here. We call this in algebra when we call it two-phase, right? So if I have two-phase and I flip him upside down, if I flip him upside down again, he's the same, right? Okay, so that being said, I need you to be very careful with parentheses. 3m to the -2. -2 is being applied to m, not the 3. Correct? So this is actually equivalent to 3 over m squared, which is different than this one. What makes it different? Because the -2 is being applied to the 3 as well. So this one is actually 1 over the quantity 3m squared, or 1 over 9m squared. So very different answers, correct? Just as these two are very different. So this one says, I have m to the -2 power, and then I'm going to take the opposite, which is the same as saying -1 m to the -2. Is -2 being applied to the -1? It is not. So I actually have -1 over m squared. And this is where second period lost it. They said, but you're squaring the negative. It's got to be positive. And I said, no, I'm not squaring the negative. I'm only squaring the m. So for instance, I have, this one is -m to the -2. So that's saying, thank you, that's saying that I have 1 over the quantity -m squared, correct? Which is 1 over, now I can apply that square to both the negative and the m. So now I just have m squared. Everybody okay with that? I don't believe you. Okay, so is this, what's the answer to this? -4. See how that's different than this? That's +4. So it was just period 2? Couldn't possibly be. It was every single person in period 2 did not know. They all argued with me. They said, well, if you put that in a calculator, it's going to be +4. And I said, no, it won't, because order of operations says, what's the first thing in order of operations? Parentheses. Are there any parentheses here? No. What's the second thing I have to apply? In exponents. So technically, I shouldn't even be able to deal with the negative yet. All I can do is square it first. So after I square it, then I deal with the negative sign. Moving forward? Okay. I'm sorry. Yes, please copy it down. Thank you for your reminder. All right, so let's do these 3. We're going to do them nice and easy. So simplify. I've got m cubed 3 times, so that's m cubed 3 times. I've got n to the -3. This can be done 2 different ways. N to the -3 3 times. So n3 3 times is n to the 9th times n to the -9, which is 0, which is 1. But we're going to do it 2 different ways. Do you? You get it? So you can pick whichever way you like better. So if I'm saying n to the 9th times n to the -9th, I'm actually saying n to the n minus 9, which is n to the 0, which is 1. Correct?
Yeah.
Here's the proof of that. N to the 9th looks like this. N to the -9th, negative exponents are positive fractions, right? Well, if I wrote out 9 n's and another 9 n's in the denominator, don't they cancel each other out?
Yeah.
Which equals 1. That's why n minus n, I'm sorry, 9 minus 9 equals 0 is 1. How you guys doing?
Pretty good.
All right, let's do this one. Okay. Also 2 ways to do it. Okay, remember our inverses? So if I can either apply my -2 to the numerator and the denominator, or I could just say, well, the inverse of -2 is +2, and the inverse of CD over 3 is 3 over CD. And then apply my exponent, which is my favorite way to do it. I'd much rather just get rid of the negative exponent right from the very beginning. So, yes, thank you. I guess I should say everything in the denominator. So I have 3 squared divided by c squared d squared, should have equal signs here, which equals 9 over c squared d squared. Anybody want me to do it the other way? Apply the negatives first and then change everybody? I think this is much easier. So let's do the same thing with this one. So I'm going to right away take the inverse of what's inside of these parentheses and say I have 3x cubed over -6x to the 6th is now raised to the +2. Now I'm going to apply that 2 to everybody inside of the parentheses. So I've got 3 squared, x cubed 2 times. I've got a -2 times, which just makes it a positive. We should probably put that just in case. And a 6 squared, and x to the 6th 2 times, which equals 9 times x to the 6th, negative times negative is a positive. 6 times 6 is 36. X to the 12th. Now, some people would take this x to the 6th and put it in the denominator and make it a negative 6 and add their exponents, which is totally doable, or I like to see everything, so I'm just going to factor it. 9 times x to the 6th, 9 times 4, x times 6, I'm sorry, x to the 6th and x to the 6th. Isn't x to the 6th and x to the 6th x to the 12th?
Yeah.
Then I just have to simplify my 1's, and I'm left with 1 over 4x to the 6th. Yes. Yes, I could have. Absolutely. Any more questions? All right, so what did you learn today? I am. What did you learn today? Anything?
Nothing at all.
Nothing at all, huh? All review? Properties of excellence. Thank you. What is the difference between the product of a power and the power of a power? Justin? Adding. Power of a power is multiplying. Product of a power is adding. Good. The person next to you is absent. How would you explain how to manipulate negative exponents? Good, but specifically negative exponents are positive fractions, right? Which brings us to our final thought. Negative exponents are what? Positive fractions. Good job, guys.
You have to write it all?
No, just what's in the box.
Wait.